We start with a fairly regular one. If you have secant, cosecant, or cotangent, it's usually a good idea to just change them into things with cosine and sine. Cotangent is the reciprocal. It is cosine on top over sine. The cosines cancel, bing, bing, and then you have 1 over sine, which is cosecant. Okay. Cosine, oh, look, I see a pair of cosine squared. So let's factor out common factor. I'm not going to immediately turn cotangent and secant into things yet, because the Pythagorean identities have some, like, 1 plus cotangent squared is cosecant squared, so that might happen. Let's just see. Factoring out the common factor, don't forget the 1 plus. And then the second term has cotangent squared. Oh, look at that. Now I'm going to turn things into sines and cosines. Let's see what we can combine and or cancel. Looks like things are not canceling. I'm going to rewrite this one as cosine squared times 1 over sine squared, and then flip the 1 over cosine. And I think that may be as far as we can go. That one could have been designed better. Oh, look, in the numerator, that's 1. So sine and cosecant are reciprocals. So 1 over cosecant is sine. 1 over cosecant squared is sine squared. But this last one requires a little trick. So this might be a level 3 question. So we're going to have 1 minus cosine squared over 1 plus cosine. And 1 minus cosine squared is a difference of squares. Oh, look at that. The 1 plus cosines cancel. Okay. So I'm going to take this left side of this one . Okay. Sine joins its buddy in the denominator. Okay. Common denominator, so I'm going to have to multiply this by sine x. remember when you're adding or subtracting, you need to get it to a common denominator. So the common denominator is going to be cosine times sine. And we have 1 in the first term and then minus, oh look, sine squared. And 1 minus sine squared is something we know. And we'll cancel a cosine. And we end up with cosine over sine, which is, in fact, cotangent. Yay. Okay, what about this next one? Secant is 1 over cosine. Oh, look at that. Oh, sorry. Cotangent has cosine on the top. Okay. So these cosines can cancel, and you'll have 1 over cosine over sine. Or you could have left it as cotangent, because 1 over cotangent is tangent. Keep, change, flip if you want to do it this way. Okay. Oh, a few more. They're good for you. Oh, this one's kind of takes a while. Let's see. Mostly because these are tall. Let's see. Going to do a common denominator, cosine x on the top. And a common denominator of sine x on the bottom. We're flipping the bottom, and the bottom is this guy. So okay, addition is commutative, so we can cancel these. Oh, look, we've got sine over cosine. We'll rewrite this one. We'll write those and those. So. Okay. Common denominator is sine, so I'm going to multiply by sine over sine. And I get sine squared. You can probably see where this is going. Sine squared plus cosine squared is still 1. And it's equal to cosecant, so yay. All right, this one's shorter. Yep, sines cancel. Okay, 1 minus cosine squared is sine squared. And 1 plus cotangent squared is cosecant squared. My suggestion is before you even start turning cotangent into cosine over sine, look for the Pythagoreans when you see squaring. Oh, look, cosecant is 1 over sine. So cosecant squared is 1 over sine squared. Yay. Okay. And 7/6 stuff. The stuff we love the best. Let's move the 4 over and divide by 3. So don't forget the plus or minus. Okay, that's one of the biggest things people screw up. Square root of 4 is 2, so let's just flip this and say sine x is plus or minus, flip the 3/4, the 4/3 to a 3/4. So sine x is root 3 over 2. Oh, we've seen that before. Or sine x is negative root 3 over 2. Doesn't say whether it's degrees or radians, so I'm going to just do radians. Pi over 3, and 2 pi over 3. And for the honors, so okay. So for the regular, we're going to just put them on the unit circle. For the honors people, we're going to say, don't forget you go around a circle and you get to the same place. And so it'll have the same answers. Negative root 3 over 2 is the third and fourth quadrant versions. So okay, we'll give you a little bit more room on the actual thing. Factor out cosine. And don't forget that you set each one separately to 0. So if you get a solution, which sometimes happens, of a number for sine and cosine, numbers bigger than 1, not allowed. Cosine is 0 on the y-axis when x is 0, so, sorry, not when angle is 0, but when the x-coordinate on the unit circle is 0. Again, those are plus 2 pi n's for the honors people. All right, set each factor separately equal to 0. Oh, sorry, root 3. Sine of pi over 6 is 1/2. And the other quadrant where the sign is positive is second, so 5 pi over 6. And again. And cosine is negative root 3 at 5 pi over 6, which is a duplication. And second and third quadrant is where cosine is negative. So this will be a slightly different one. Okay. Factor this one. Doesn't have a common factor, so we go to the 2 parentheses part. And 2 sine squared factors just like 2a squared, 2a and a, 2 sine x and sine x. Put the 3, I need to get the 3 across from the 2 so I can get a 6. And then a 1. That'll give me my 7. We need them both to be negative. So then we just set each one separately equal to 0. Okay. Find the exact value. Some people got this, some people screwed it up. If you've got a mix of sine and cosine, and then you've got a minus, this is, first of all, mix of sine and cosine is sine is the sine angle addition formula, and because it's minus, it's subtraction. Once you get the hang of doing this, they're very straightforward. Don't forget to find the final answer. Sine at 90 degrees is 1. There you go. Okay, so a little note for this one if you end up with radians. Pi over 6 is 2 pi over 12. Pi over 4 is 3 pi over 12, because we're just multiplying by the, to make a common denominator. I want to make a denominator of 12 so I can compare things. And then pi over 3 is 4 pi over 12. So if I wanted 7 pi over 12, I could combine pi over 4 and pi over 3. Since I want 5 pi over 12, I think I want 2 pi and 3 pi. So, oops, turn it back to red. Yeah, I'm OCD about that. Okay, then we look up the sine formula. Sine, I'll write that in green. Sine alpha plus beta is sine alpha cosine beta minus plus cosine alpha sine beta. So we just stuff in the appropriate numbers. Okay, sine of pi over 6 is 1/2. At pi over 4, both numbers are root 2 over 2. The other number that goes with 1/2 is root 3 over 2. When you're multiplying, you multiply straight across. 1 times root 2 is root 2. 2 times 2 is 4. And when you're multiplying, you can just combine these, multiply them together. And when you're adding and subtracting, you just have to use common denominators and note. Addition makes things tough. You can't combine with the addition. You can combine with the multiplication, but you can't combine with the addition. All right, secant. We're going to flip cosine of 105. All right. 105 is 60 and 45. One hint is, if you have a number ending in 5, which you usually do, try 45 or at worst 135. You can do 135 minus 30 also. That will work fine. The cosine formula, the differences are that you have cosine, cosine, not mix. And also it's opposite signs. So if this is plus, then this will be minus. Get to hear the next door neighbor dog. Oh well. Sine of 30 is 1/2. Sine of 60 is root 3 over 2. Cosine 60 is back to 1/2. And this is why we do a common denominator, because don't forget, you have to flip. Notice that's a negative number. Cosine does go negative in that quadrant, so that's all good. Okay. I'm going to draw acute angle in the first quadrant, so okay, so then sine is opposite over hypotenuse. It's always opposite. Sine is height, except it's not a unit circle, so 2/7, we'll put it that way. You can do 2/7 and 1, but then you're condemned to figuring out the Pythagorean theorem with fractions. This side is square root of 45 because it is square root of 7 squared minus 2 squared. Remember, you have to subtract when you know the hypotenuse. We said that a few times last term, and we've said it a bunch more times this year. Okay, tan is opposite over adjacent, so sine. Let me write cosine, because that's a useful one to know. Cosine will be adjacent over hypotenuse. Secant flips cosine. Fine. How do you do sine and cosine? How do you do the double angle formulas? It says sine 2 theta is 2 sine theta cosine theta. So sine of 2x is 2 sine x cosine x. And it is sine x is 2/7. It is, so a little note, some of my students are having issues with this occasionally. It's the sine of x is just the number 2/7. Cosine of x was square root of 45 over 7. Put the 2 over 1 and multiply straight across. And I will make another note. for the honors students especially, but, you know, whatever. Okay, cosine of 2x is cosine squared minus sine squared. Okay. Solving things with the law of sines. This one is an ambiguous case. It's SSA. So we check for the honors students. You check is, so the side actually opposite is the 16 is 16 greater than 22 sine 38, and is 16 less than the actual 22. That's true, and this is also true. So there's two solutions. If this number is big enough, then it is bigger than the height. So it can be waggled back and forth. We have to tip the triangle around to see it, but I'm not going to worry about that. I'm setting things up for two possible solutions. Oh, I should probably just do this all in blue since it's going to be honors only. We will leave you lots more room on the actual thing. Let's see, K is 38 degrees. And side K is 16. So we can set up law of sines. J is 22, because it's across from angle J. Okay, so we'll set up law of sines, and the two angles that are supplementary are the two angle J's. So we'll set up and find angle J first. Okay. Cross multiplying and then dividing by 16, which was stuck to J. And then we do second sine. J is sine inverse of that. Let's see, what do we have then? I got 57.8 degrees. So this is 122.6 degrees. Then the next step is to find the third angle. And set up two sets of law of sines. I'm going to use the K proportion anyways. So for the first one, we have sine 38 over 16 is sine 94.2 over I. Okay, and then we just cross multiply and divide by sine of 38, and we get I in both cases. Notice when I is a small angle, it comes out to a small side. When I is a bigger angle, it comes out to a bigger side. Okay, this is, okay, is this angle side or angle side angle? This has two angles, A, B, and side B. So this is going to be an angle side. But regardless, if you know two angles, you can find the third angle, and then it's basically the same as angle side angle. If you have two angles, it's law of sines. But also, I'm going to call the third angle C. Okay, we find the third angle at the beginning, angle C. Makes it total to 180. People seem to be pretty comfortable with that. And the B is 10. So again, if you have an angle and a side across from it, you set up the law of sines. And then pick one. I think I'll do A first. You just do it twice, so one for each one. I usually put the A in front of the angle part, the side in front. Doesn't really matter. Divide by what's stuck to A. And then and also something I've been making note of in the notes is that you end up flipping this, and the only thing that's different is the angle here. I'm going to say save time for B. You'll just swatch out angle 38 for angle, or sorry, not B, C. Keep doing that. Third angle is 83. And C. Okay. You follow the same procedure and stuff into calculator. Okay. This one is not ambiguous. Okay, so I'm going to just say for honors purposes, the 73 is bigger than the 40, and so we're back into that third case of that being the biggest side. Oh, sorry, it's not 73 degrees, it's 73. Okay. Ooh, I forgot to figure the numbers out on this one. sine inverse. So I'll just write it here. Okay, let me just type that into my calculator fast. Don't, yeah. Oh, oops. So 28.01 degrees. Okay, and then we set up the same sets of proportions to get G, but using G's angle. Okay, so we get 43.85. Good enough. Okay. Welcome to another ambiguous case, SSA. So for honors, again, the 18 is across from the 41, so we'll take 25 sine 41 and see if 18 is in between that and the 25. That's clear. This is 16.4, so yes, so there's two solutions. Okay. I know this is going to make this video take forever, but oh well. Okay, so the angle that we're first finding is this one. And so that's the one we'll do the supplement on. Oops. Okay, so S is going to be 65.67 degrees or 114.33 degrees. Okay, and then we can find R next. And last, we set up two proportions to figure out the two little r's. So, Okay, so you get your two R's. Notice that in this first case, big capital angle R is a little bit bigger than angle S, so side R is a little bit bigger than side S. In the second case, it's a lot smaller than angle S, and it ends up being the smallest side. Okay. Again, not too worried about actual precision. Law of cosines. I like to, again, set it up. I'm going to do it back in red. This is back to regular. Okay, so again, if you're doing angle side angle, and we know we're doing law of cosines because we have an angle and we don't have a side across from it, then we solve for the side that's across from the angle first. Okay, that's a number. It's 79. Cosine 60 is a half. That's why it comes out to a nice whole number. But C is a decimal. Okay, and then we set up the law of sines. And find the smaller angle in case the other one's bigger than 90 degrees. Because it can't tell whether angle B is more than 90 degrees or not. It'll only give you an answer less than 90 degrees. And if it's not supposed to be, then we have a problem. Okay, so cross multiplying and then dividing by 8.888. And then doing second sine, you get 16.996 degrees. And once you've done that, you find B. Oh, look, B was bigger than 90 degrees. Okay. Same thing here. Don't forget to take the square root. And we set up one more. Find the smaller angle. Doesn't matter this time because you can't get an angle bigger than 90 because the other two already have to be less than 90 total. But it's a good habit. Okay, cross multiply. And then second sine to find the angle. And then subtract from 180. There you go. All right, next, this is angle side angle. Do I have a law of cosines with three numbers? No, I don't. Okay. Oh, I'm just going to write a little note. This is another side angle sine. Okay. Side. Incidentally, yeah, let me just write a note. And you can do, if you do have side, you can do law of cosines twice. Find the third angle by subtracting from 180. Okay, so law of sines, it says to actually solve it. We don't have an angle and a side across from it, but we can find the third angle easily. So stuff into calculator, 32 degrees. Now we have an angle and a side across from it. Okay, so B comes out to 80.13. And again, you can just substitute in angle C to find side C. Okay, law of cosines. Lots of problems with law of cosines. So. Okay, so let's stuff in the things we know. The 15.4 and the 12.9 are interchangeable. Sorry. So D, don't forget to take the square root. Setting up a proportion, find the smaller one, find E. Cross multiply, divide by 10.674, take the arc sine. Subtract from 180. Okay, enough. All right. One tricky problem. We've got an elm tree. And she goes, finds an angle of 17 degrees. Then she goes 30 feet further away. And then the angle is 15 degrees. So what we're going to do is we're going to do this in two steps. First, we're going to look at this triangle and figure out what this is. And then we will look at this triangle and figure out what the height is. Okay, so let me just draw this triangle out here. Yes, I need the angle. Let's see, I've got the angle across from the 15. I need the angle across from the 30. How do I find that? Well, let me make this really large for a second. If this is 17 degrees, then this on the inside is 180 minus 17 degrees, which is 103. Sorry, 163. So I can figure out that this angle here is 2 degrees. All right, so we'll set up law of sines because we have two angles, side across from them. All right, and then we go to this one and we say, this is a right triangle, so we can just say sine of the angle is opposite over adjacent, a hypotenuse, so. Okay, well, that was tricky. All right, on these area of a triangle is 1/2 side, sine of 1/2 side, side, sine of angle in between. So let's just make sure on these things that we have the angle that's in between. Let's see, this is angle B. We have side AB, that's good, and side BC is 9. Okay, we have it set up. If I had the third side, if I had the side across from B, I'd have to set up the law of sines to figure out the side that was next to B, angle B. Okay, same thing with this. Let's just triple check to make sure. D, E, F. D, E, F is 28. D, F is 34, and it is angle F. Oh. Wait a minute. D. Oh, I put the 34 in the wrong place. That's DF. That's fine. Okay, and angle F is given. So we are ready to go. Oops, where am I? That's the answer to the next one. All right, we need this angle because it's these two sides. So almost done. All right. This is two angles. This is ASA. This is law of sines. Anytime you have two angles, or an angle and a side across from it, you have law of sines. This may be the ambiguous case. Is it? No, because the 117 is bigger than 90, so there's only one. This is side, side, side. is law of cosines. Side angle side is also law of cosines. And this is angle side. Two angles, you know it's law of sines. Because you find the third angle, and then it doesn't matter whether it's angle side or angle side angle, because you got 3 angles already. You got a side. Okay, so why is this so the reason, even this, though this is side, the problem is 21 is bigger than 12 plus 7, and you can't make a triangle out of it. Okay, what's wrong with the next one? Angle. If there's no sides, we don't know how big it is. Okay, what about this one? This one, the problem is angle A is the largest, because you can't have anything else bigger than 90 degrees in a triangle. But side A is not largest. So angle B would have to be even bigger than 117, and that's not possible. Okay, let's just see.